Let us talk about experiments, shall we, cabbage? That's a lettuce joke. Experiments. Why would you do an experiment? Because you want to prove that something has causation. That is, one thing causes the other thing to happen. Right? Not correlation, where two things just happen close together. The street light turns from red to green, and vehicles start moving. But did the light make them? Were there strings attached to the light and all the vehicles, or some kind of cable? No, it's just a correlation. People know or understand the rules of the road, and that's how the streetlights work. An experiment has two variables. A pseudo or quasi-experiment has more than two. Let's say in the stereotype we're doing a experiment on medication. You have one group that takes one medication, one group that takes that medication plus another medication, and then you have the control group. At the end of the experiment, what did you learn? And the answer really is nothing. The one group can be judged, the one that took only one medication can be judged against the control group, but the one that took two medications can actually not be critically evaluated, because we don't know how those two particular medications work together. So, experiments, two variables. I want to talk about the placebo effect. So let me back up. What is a placebo? A placebo is something you give the control group to make them equal to the experimental group. Let's go back and use the drug study. Let's say that you have a cancer-fighting medication. Well, you have one group that is, we have two groups that, let's see. Yeah, two groups that are sick. Sorry. So one group you give the active medication to, and the other group who are also sick, you have to give something to. Because if you just left them alone and did absolutely nothing, then they would know they weren't getting anything. I guess that's the point, is a placebo makes the participant think that they are in fact getting something. Now this can get kind of complicated. I read a study in which it was about seasonal affective disorder. They gave one group a lamp that had a full spectrum light, which has been shown to help improve mood. I don't know if that does actually do something to help them. They gave the control group a little box that made a really annoying noise, and they told them it was giving off positive ions, and they need to bask in the ions. So that was the placebo, but in my mind, that is not the same. The groups were not similar. One group got a lamp, but the other group got a noisemaker. That's not the same. Now, if it was me doing the experiment, because I can be kind of a jerk sometimes, I would give the one group the full spectrum light, and I would give the other group a lamp that was broken. And then I would just tell them, it's a light that you can't see. Right? I mean, that would be kind of cruel, but now they are in fact the same. The group that got the placebo, the lamp that was broken, really did think that something positive was going to happen. How long does the placebo effect last? Not very long. Probably, I mean, if I was going to make a total guess, and it is a total guess, I would say not more than about 7 to 8 days. You give, in the standard medical test, you give the control group a sugar pill, which actually does nothing to help them. And you tell them, oh, this is really strong, you can only take one pill at a time. It probably won't take much more than, say, 2 or 3 days, because these people really are sick. 2 or 3 days for that person to say, doc, this really isn't working for me. I think I need to up my dose. So they recognize that something is not happening. Something should be happening is not. You give them another, so you give them now 2 sugar pills at a time. And my guess is it will that effect for them thinking that they're being helped will not last more than another day or so. So probably not more than 7 full days. However, the odd thing about the placebo effect actually is that let me back up. They did a study with children who are cancer patients, so they were very ill, and they did guided imagery. One group, now remember, they're both sick, they're both, in a bad way. One group just got their therapeutic treatment, the medicine. One group got therapeutic treatment and they got visualization, guided imagery. That is, they had time where a therapist would tell them, imagine that this drug is like a fiery sword and you are fighting the dragon, and the dragon is cancer, and every time that you get your medication, I want you and me to go through this visualization about you fighting the dragon. What happened is that those children who got the visualization had stronger immune system responses and had better quality of life self-statements. That is, when you ask them, how are you doing, they were much more likely to say that they were doing, about as well as you can be when undergoing those kinds of circumstances. Just really quick, there was another experiment in which I call the boiling acid trick. A person was hypnotized, and while they're hypnotized, they were told that water, like a little Dixie cup of water, was acid. And the experimenter took their finger, not the hypnotized person, but the researcher took their own finger, dipped it in the water, and then put a drop of water on the back of the hypnotized person's hand. Well, of course, the hypnotized person, like, oh, it burns, please get it off. Well, when they wiped the water away, what do you suppose they found? There was a red mark right where the water had been, but not on the outside from being burned by imaginary acid, but a red mark from the inside, meaning that the person's body expected that they were being burned, believed that they were being burned, and actually sent an inflammatory response and an immune system response to an area of the body where nothing was really